Oh man, I'm hungry. Dun, 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 dun. Uncooked? I'm not that desperate yet. Okay. New chapter. Last chapter of semester 1. If you're good at English, you'll like this chapter.
How long is it?
Why are you laughing? 5 lessons.
Well, I know it's not good for me.
Don't say such a thing. Don't say such a thing.
It's good for the...
And your English is very good.
Yes.
Wave motion. Maybe you want to wake Faisal up for the new chapter.
Good choice.
Wave motion. You got that? Lee? Yes? Yeah. What a fool, huh? Alright. Continue.
Go back.
Wave motion. Okay. 2 types of waves. We have what's called transverse waves, or S waves, and also longitudinal, or P waves. So, transverse wave is a moving wave that's made up of oscillations happening perpendicular to the direction of the transfer of energy. So, exactly. He's right, you know. If the wave is heading to the right, then the oscillations, the vibrations, happen perpendicular. Oh, Faisal, tone it down a little bit, please. Shaken. Vibration.
Like this.
Yes. What?
Like Parkinson.
Like Parkinson, yes. Where did you learn this? From your biology class?
No.
From pharmacy?
I have Parkinson.
You do?
Yeah.
True story?
True.
Really?
Yeah, my grandpa.
You have it, or you think you have it?
It's Jen.
She's a carrier of the...
Yeah, my grandmother and then my dad.
Let me put it this way. Are you taking medicine for it?
No.
Then you're okay. Maybe later.
No, but I have no.
You know for certain?
Yeah.
Oh, okay.
It will get back when I grow up. More
Oh, that's later. Don't worry about that.
But now it's chocolate.
For now, eat chocolate and be happy. Yes. So, Parkinson, maybe not the right word. Do we have other synonyms for oscillation?
Vibrating.
Vibrating, do you know this word?
Shaking.
Shaken?
You know when you take a picture with the Polaroid camera and you shake it? Shake it.
Do we have any other synonyms for it? No. It means shaken like this. So, transverse wave moves and oscillates in a direction perpendicular to the movement of the wave. We're looking for simple synonyms.
Shivers.
Shivers.
You know when you're feeling cold?
Yeah, fever.
Fever. Fever is. Yes. Okay. That is transverse wave.
I'm not used to this not having sun.
I've bad news for you. You
Yeah.
need to get used to it. It's not a problem that's going to go away.
For the next 4 years.
Yes.
Like it's draining all my energy.
Yeah. No, I like not having the sun. The sun used to drain my energy.
Yes, me too.
Yeah.
2 things drain my energy. Students and heat. Both together, no good. Don't like it. This is why I like to have the windows open.
So let the steam go out.
Yeah. Yeah. Okay, did you write this definition
I
down?
can leave and help, but I would rather.
Is it all students or just paper?
Ah, no, in fairness, it is all students.
No, but
But
like
just percentages, yeah, it's a weighted average, you know, it's like
50%.
I'm dragging you guys down.
yeah,
If it's
yeah.
in the exam, can
And it's also distance as well, you know, closer means more higher risk, you know. Yes? In the exam,
Yeah,
can you write this?
in like shaking.
Vibrating.
That's vibrating.
It means shaken.
I don't know that one.
I'll write it down. Where'll I write? I'll write it here. Vibrating. Yeah. Okay. The next type is longitudinal. And in this case, the particles do not move with the wave. The particle movement is parallel to the direction of the wave propagation. This means that the particles move left to right, which in turn make the other particles start to oscillate.
Longitudinal.
Yeah.
Longitudinal.
I thought it was longitudinal.
Please do not take my pronunciation as the correct one. I'm willing to accept that
No.
I could be saying it wrong.
No,
I have a question.
Is it about the pronunciation of
No.
longitudinal?
The definition. In longitudinal wave, the particles do not move with the wave. The particles move in parallel to the direction of the wave.
Yeah, explain the difference here in my picture. So before you write that down, in this picture here, the particles are actually moving with the wave. So we say the wave, a little bit of vocabulary, verb propagate means move. So we say the wave propagates from the left to the right. Also the particles move from the left to the right. However, in the other type of wave,
They don't always move with the wave. They move left and right.
yeah, exactly, they kind of stay in the same location and are just vibrating. So what happens is these particles here vibrate and then they knock and cause these particles to vibrate, which then cause the next ones to vibrate. So the particles don't actually move anywhere. It's like dominoes. These ones vibrate and hit the next one and vibrate. Thank you for the demonstration. They kind of cause the neighbours to move, but they don't actually move. They just vibrate in the same location. So that's what I mean by they do not move with the wave. The wave propagates from me to you, but the particles do not move from me to you. They just vibrate their neighbours, and the vibration moves along. Longitudinal. Longitudinal. Close enough.
I tried, but like I didn't know that it had an N and an IN.
Oh no, it definitely does.
Yeah. Probably where I lost a lot of
No. Okay. If you don't like these words, you can say P and S waves. And I forgot what the S and the P stands for. It's not something we need to know for the exam. I think P is progressive waves and S is... I don't remember. Shaken waves?
Wow.
Sinusoidal waves, perhaps?
That's wave is fine.
Okay. Hang in there, Faisal.
I'm remembering that I did before coming here. We were doing vocals and audios and supersonic waves.
Boring.
Yeah, it was boring.
Do we have...
Acoustics. We're doing acoustics in engineering in university before coming here.
Boring.
Yeah.
Give me mechanics.
That's what I told the teacher.
I said, Faisal, get out. Right, did you write that down?
How many percent of the theory in the exam?
You mean definitions?
Yes.
100 marks, it would be
8, 12.
yeah, around about 5 to 10 marks. Maximum 10, minimum 5.
So the first semester is 10% and the final is 70. What's the 20?
10.
No, 20.
No, what's the left 20?
Yeah, 2 courseworks of 10.
Oh.
The one you're doing in a week's time is worth 10%. Okay, continue. Yes? So, this creates wave. Here is a nice diagram illustrating the two types. The P waves, the vibrations cause the neighbours to vibrate. So here's the wave moving across. Here's the wave here now. This will vibrate its neighbours. It'll hit the wall and come back. And S waves, you flick and the hill runs through the wave. But I think you have a good picture in your mind of this. Now, the parts of a wave. So wavelength is from crest to crest, or also from trough to trough. Amplitude is half the total height, or in other words, the middle to the highest.
The height of a crest or the...
Yeah, the height of a crest, yeah. And displacement is the height in general. Now, there are synonyms here. So what's a synonym for crest? Peak.
Optimum.
Peak.
Oh.
And what is a synonym for trough? Dip or valley? Yeah. Mountain, yes, okay. Can you write this, can you draw and write this down? Thank you, that's enough synonyms, thank you.
What did you say about the amplitude?
It's the height of a crest. We've seen this word before, amplitude, in the mechanics. Yep.
This is only for the transverse.
No, it's weird. It's the same vocabulary for the longitudinal and the transverse. It's just you have to convert the longitudinal diagram into a transverse diagram, which we actually haven't seen yet how to do. So I know it seems a bit weird, but this vocabulary is for both, even though I only have the picture for one. So you might be saying, well, how on earth do you find the wavelength for a...
Compression to compression.
Yeah. How do you find that one? Yeah. There is a way to convert one wave into another, which we'll do. I don't remember. I don't think it's this lesson though. Okay, have you got all of that? Yeah? Okay, so displacement x. How far the particle is displaced by the wave, obviously. Amplitude is the maximum displacement. Wavelength is the length of one wave from peak to peak, for example. Period t, what do you think that might be? Yeah, time for what though? For one wave to pass through. Yeah. The time taken for one wavelength to pass. Phase difference.
The time difference between the same particle, not the same particle. Particles are the same, with the same displacement. Yeah.
So your answer is?
When the two particles are the same.
The time difference between the peaks of two different waves moving together.
Has to be a peak?
It doesn't have to be, no, but it usually is. So what happens here is, actually I think I have a picture coming up. Here's one wave in blue, and here's another wave in red, and they both move together. The phase difference is the difference in the distance from the peak to the peak. So this is the phase difference. When they're in phase, it means the phase difference is zero. And so, in my picture, they would line up. Now, I think I have a nicer picture coming up. I don't know. Frequency F is how many cycles are completed in 1 second. Speed V is, of course, how fast the wave is moving. So please write the new terms you didn't know down. Nobody knew phase difference, so everybody has to write at least one thing. Faisal.
Yeah, so the first time. I write it. I forgot.
That's okay. I don't need a question from you. Yes.
Oh yeah, there is in phase, there is out of phase,
Yes.
and there is one more.
Is there? If there is, we don't do it on the course. We just do in phase and out of phase.
What's the difference between frequency and period?
Period is the time taken for one wave to complete, so it's seconds, whereas frequency is the number of waves that travel in a second. Yes. Got this? Oh, come on.
Will we do interferences?
Okay. You writing everything down for him?
Good English practice.
True. Maybe we should make her read it all. Better English practice.
Cycle.
What is cycle? Which one is that in frequency? Cycle means like loops, journeys, wavelengths. How many are done in 1 second?
Look. One cycle.
Oh,
Two cycles.
the orbital.
Yeah, so
but in this one.
yeah, so 1 cycle of a wave would be this. So if in 1 second you have this, that's 3 cycles, or what adds.
When it goes back to the same place it started from. Please, yes.
Yes. Paper. No, I want the work too. Please, don't just give me the answer. Please don't do this. Okay. You have this now? Yes? Okay. So, we have the wave equation. Our first equation of this lesson. It's an equation to calculate the velocity of a wave. So, the formula is quite simple. Before I get to the new formula, let's just remind ourselves of some old formulas. F equals 1 over T. In addition to this, we now have this other formula as well. V equals F lambda. The speed of the wave is equal to the frequency of the wave times the wavelength.
Human.
Human?
Yeah.
What's
Lambda.
human? Lambda is human?
Yeah, human.
What are you talking about?
Human.
Don't care. V is the speed, F is the frequency, and human is the wavelength. The wave equation. Please note that. It's our formula for today's lesson. Now, if you think about it, it kind of makes sense because of the units. What is the unit for F?
1/T.
1 over seconds.
Yeah.
And the unit for lambda? Meters. So the unit here is meters per second, which is kind of what you want because of the V. Okay, do we have this? Yep, okay. Examples of transverse waves. So they sometimes in the exam ask for an example of a type of wave. So what are examples of transverse waves? What?
It's either light or sound. One of them is transverse. and the
What
other-
are you trying to tell me? Okay, you don't need to be that specific. Sound is, you're saying transverse.
Yeah.
Are you
No.
sh-
Yeah.
no.
No. Yes.
Oh,
Yes.
horse.
Yes.
No.
Transverse sound.
Sound is not transverse.
No. Light is transverse.
That's not transverse.
Oh, horse
This
rider.
is transverse.
Light. No.
Yes. Yeah. So examples are light waves, ocean waves. Obviously, it goes up, down, up, down, up, down. And waves in a guitar string.
This is not sound.
No, the actual string, not the sound it makes, yeah. These are examples of transverse waves. Now, what about longitudinal waves? Sound waves. Anything else? No. Huh? What?
The toy.
The slinky? Yeah.
Yeah.
We'll go with something else. True.
Microwaves.
Underwater waves. Waves that move in the deep ocean under the sea level. I know that might seem a bit strange because we just said it was ocean waves a moment ago, but the difference is this. The waves on the top of the ocean are transverse, but any waves that move under, these are longitudinal. Yeah. And lastly, waves, like you said in the toy, we'll go with a spring, an oscillating spring rather than a slinky toy. Three is always a good number of examples, so if you think of more, that's great. Okay. Continue? Yes?
Heat is transverse or longitudinal?
Does anybody know heat moves as a wave, like the heat moving through a table? If I put a heat source here, the heat moves through a table, which,
Longitudinal.
yes, it has to be because it's not vibrating like this. Okay, I think, yeah, I'll do this one, but I'd like you to try it first. See what you can come up with. There's only one formula for today, and you can use the other formula, F equals 1 over T as well. Yeah. You know Bob's?
The builder.
No. The verb, not the noun. So, do we have an idea on how to do this? Can you try this now? And then I'll do it.
I hate it when it's working, but it's no break.
Right, so, yes. What? What? What did you guess?
2-1.
Right, let's have a look. So, a boy is sitting in a boat which is tied to a dock. We'll put a little house there for him. Right.
That's a sad house.
It is quite sad looking, I agree. The boat bobs up and down at a rate of once per 2 seconds. So the boat is moving up and down, and the time is 2 seconds for a bob. The boy judges the distance between the peaks to be 4 meters. So from peak to peak is 4. What exactly is the 4 meters here? The wavelength, yeah. How fast are the ocean waves moving? Well, V equals lambda F, which equals lambda times 1 over T, which equals 4 times 1 over 2, which equals 2. This is not wavelength? No phase difference. It's one wave. Yeah. Sorry, I know that's bad. It's one wave. Yeah. One wave moving in. Not phase difference problem. No? What did you get, guys?
2.
No, 2 peaks on 2 different waves. You must have 2 waves moving together. There's only one wave here, one ocean wave. Yeah? Are you sure? I don't know. Anyways. Okay. I think what we'll do, we'll have a double tutorial. So we'll do these ones together. We'll finish them in like 5 minutes, and then I'll let you work on the homework from the electricity. That way, when we have the next lesson, we only have one homework to do, and we might get 2 waves done, which means there's a chance we could get waves finished this week, although I don't think so. It'll be the start of next week. So we might have 1 or 2 classes for revision then, okay? So we'll do these together, we'll take turns. Try the first one, should only take you 1 minute, and then I'll do it, or less than a minute. Write it down, please. Question 1, please.
Can I just see?
I haven't taught you C yet. C? No, definitely not. There's no C in question 1.
Is this more?
Huh?
Is this the homework?
Yeah, but we're going to do it now, so there won't be any homework.
You still have the whole 2 weeks after the
No, it's not that long. It's like 2 weeks.
You got an email, it's on the 10th of April.
The 10th of April is the physics, but that's not the first exam.
Yeah.
The first exam is chemistry, which is on what date?
Should be on Friday.
That is on the 7th.
Yeah.
It does, because classes end the minute the exams begin. So Thursday is the last. Flip. So that means that Friday, the chemistry stinking exam, I lose physics.
Oops.
Which this Friday the exam starts?
No, you have chemistry exam on Friday the 7th, which means I now lose 2 hours of physics.
Only 1 hour.
Completely.
You have 1 hour.
Is it 1 hour on Friday?
Yeah, on Friday.
Oh well, that's something, I suppose.
So we have this week and next week and the other week except
No, so what we have this week, next week, and some of the last week.
Okay, I will use my
But-
authority.
but there's other stuff going on in that week as well.
Chemistry now.
Labs are going on. I have no idea how messed up the timetable will be. What's your question?
Not a question.
Yeah.
I will use my authority.
Go on.
To give you an idea.
Go on, give me an
We
idea.
changed our timetable.
Yeah.
So now on Friday we finish 2 hours earlier.
Yeah?
So on Friday from 3 we're free.
Yeah?
So 3 and 4 we're free. So if you are free and you want to take a lesson to
And do you
come
think I'm free?
I don't know, I'm telling you, I'm suggesting.
But do you think I'm
Because they
free?
changed the timetable.
Remember, of all the teachers in DIFC, this is a fact. You can look this up on the timetable. I have the most teaching hours.
Never mind
Fact.
my suggestion.
So, Friday at 3 o'clock.
Trying to be nice with you over here.
Yes, try it. Friday at 3 to 5, I actually am teaching physics to the other students. The
Yeah.
September students.
Won't they be
Tired? Yes.
almost done?
No, there's still we still have like 7 weeks left.
Oh.
Yeah, and they start their exams earlier than us, right?
Oh yeah, they start their exams the end of May.
Yeah.
So, don't know. You can fight out with them to see who wins the time. If you have some kind of sort of Mortal Kombat duel, winner takes the 3 o'clock slot. Yes.
No, thank you.
Do we have the answer for number 1 now?
Yes.
Right, so let's calculate. What do we know in number 1? Frequency and
Whose number was that?
whose number was what?
Whose phone number was it?
Oh, sorry.
Frequency is 15.
Hold on. 15,000 hertz is the frequency, and the velocity is 330 meters per second. And what do I want here? The wavelength, probably, is it? A very small number. What did you get?
0.022.
0.022 meters, which is 22 millimeters. Okay, that's number 1. Now try number 2.
Do you think we have anything like important, like any assignments to handle in May from the 24th, like the end of May basically?
Let me just scan my database. Good thing for you is I'm also connected to all your other teachers, so I can know if they have important coursework. One moment, please.
Can we talk
No.
about physics and math?
The Wi-Fi isn't strong enough in this room. I just can't connect right now. Sorry.
About physics and math.
Yeah, physics and maths. I am quite flexible with the physics and maths. If I need to move a date, I can. I don't know.
Like if I wanted to travel
Yeah,
and
I
like
think
if I
most
was
would be
gonna
fine.
miss 3 or 4 days.
I don't know. To be honest, I haven't thought that far ahead. I haven't even thought as far ahead as your exam in 2 weeks.
Because apparently
I operate on a much shorter scale than this.
no, because like I had to ask my teachers for that. I know.
If I was doing an assignment during this period and you're missing 3 or 4 days, you can submit the assignment before or after these days. Well, maybe not after.
After we have a week off.
Yeah. Oh, you're trying to increase your break by 3 or 4 days. Ah, you sneaky son of a gun. When is this?
23rd or 24th.
Usually if I give assignments which are due before holidays, they always are due after the holiday. So I never ever have an assignment due before students are going on a holiday. It's always due after the holiday. So for me, it'll be okay. Right, you have 2 done. What do we know in number 2? Yeah, what's the speed here? It is 2997, 92458, and the frequency is 8 times 10 to the 14. V equals lambda f. Lambda equals V over f, which is, yeah, go on,
That's not what I got.
0.37,
Oh, yeah.
3747 nanometers. 375 times 10 to the minus 9.
Yeah, around 3.74 times 10 to negative 7.
Yeah.
Same, yeah.
Okay, 3.
I can't understand the question.
That's okay. A surfer is surfing a wave. Do you know what a surfer is? I'll draw it for you.
Australia.
Yeah.
Don't think that would help a lot.
I'm drawing the surfer. Watch this amazing picture.
Not a fish.
No. I'll even give the surfer shorts.
But it's a sheep.
Is it?
Yeah.
I know. I'm making them.
Whales can't wear shorts.
Yeah, exactly. Yeah.
To draw something else.
Surfer, you know, standing on the board in the ocean. Okay, yeah. And what's the distance between the peaks? Or what do I give you? No, I give you the speed. 5 meters per second. And the time is 2 seconds to reach the rocks. So we know the time, don't we? 2 seconds. So, and do we know anything else? And what do we want? The wavelength. Okay, so lambda equals V over F, 5 over 2, 2.5? Oh, so sorry. The F is 1 over 2. So this is what, 10. Omar. And hope for the best.
Yeah.
Next lesson?
No, I let you work on the homework from the first lesson. You,
At
no.
home, yeah, at home. If we leave early, we go home early, we start our homework early.
That's it, this is our last lesson?
And then you see them as a SU blank.
This is our last lesson for today?
This is it, yeah.
Oh. Let's start the next lesson. What is it? Like if it's just a short
have
this
our
one, might as well
homework
just
to
finish
do.
it.
Charger.
Let's see what the next lesson is.
Start on electricity homework.
Yeah.
Oh.
Look, guys, look. It's 4:27. We'll leave at 4:37. Just give me 10 minutes of homework time, okay?